Most animals that hit this hard are large. Sharks, crocodiles, things that earn the right through size. The mantis shrimp is about 10 centimeters long. It is the size of a finger. It punches like a problem. And the reason the punch is so extreme is not muscle, it is design. The appendages fold under spring-loaded tension and release with acceleration so fast that the water around them cannot react quickly enough. The water vaporizes into a bubble. The bubble collapses. The collapse produces heat, light, and a second shockwave. The shrimp hits you once. Then the water hits you again. The club-like appendages work like a crossbow. Muscle loads the tension, a latch holds it. When the latch releases, the appendage fires, not by additional muscle effort, but by stored mechanical energy releasing all at once. The strike accelerates at roughly 10,000 G. The tip of the appendage moves at around 23 meters per second through water. Aquarium keepers keep mantis shrimp in reinforced tanks, not because they are particularly large, but because they break the regular ones. But here is the part that should not be possible. The club that delivers this force does not destroy itself. At the point of impact, the club face absorbs a shockwave that would shatter most materials. The reason it survives is that the club is built in a helix structure, rotating layers of fibers that redirect the impact force as it travels through the material. Instead of a single crack propagating through the club, the energy spirals outward and dissipates. Engineers are studying it, not to understand the shrimp, to build better helmets. And when the club does sustain minor damage, the mantis shrimp grows a new one. Same helix structure, fully functional, ready to use. It is not only a weapon, it is a self-repairing weapon, which is a concept the rest of us could have used. And then, as if the punch were not enough, there are the eyes. Humans have 3 types of color receptor. That is enough to see roughly 10 million distinct colors. The mantis shrimp has 16. It does not see more colors than we do, it processes color information in a completely different way. Faster, more directly, less interpreted. Where we blend and compare to identify color, the mantis shrimp reads it like a barcode. Each receptor channel is a yes or no, not a shade, a signal. Which sounds elegant until you remember this vision system belongs to something that also punches through shells for a living. But the color processing is not even the most unusual part. The mantis shrimp can see ultraviolet light, UV wavelengths that are completely invisible to us. This matters in shallow reef environments because some prey animals have UV reflective markings, signals they use to communicate with each other in a channel they assume no predator can read. The mantis shrimp reads those signals. It sees the conversation. Every signal, every message, things that were never meant for it, in a frequency it was never supposed to have access to. It has been listening this whole time, and nobody knew. And then there is the tracking system. Each eye moves independently, not just left and right, in 3 planes, simultaneously. The mantis shrimp can track 2 completely separate targets with 2 completely separate eyes, while its body remains still. The eyes select the target, the spring latch delivers to it. The whole sequence, from detection to strike, happens faster than a human blink. The question is not why this animal is so effective. The question is why something this small is allowed to be this effective. On land, force scales with mass. To hit harder, you need to be heavier. In water, the rules are different. Water resists rapid movement, but that resistance can be weaponized. If you can move something fast enough through water, the water itself becomes part of the impact. The cavitation bubble is not a side effect. It is a second weapon that the animal gets for free. This is why a 10-centimeter shrimp can crack materials that would resist a human hand. It is not punching harder than its size should allow, it found a way to make the environment punch too. The mantis shrimp is extraordinarily dangerous to its prey. It is also, it turns out, a significant problem for things that try to eat it. Octopuses eat crustaceans. Octopuses generally do not eat mantis shrimp. A mantis shrimp that has been swallowed is not done. It can punch from inside. There are documented cases of mantis shrimp punching their way out of the digestive systems of animals that ate them. The predator won, and then lost, from the inside, to something that was already eaten and found that unacceptable. Fish that encounter mantis shrimp in the wild often leave with visible impact marks. Not kills, just warnings. The mantis shrimp does not need to kill everything that approaches. It just needs to make sure they remember not to come back. There are also documented cases of mantis shrimp attacking and cracking diving masks, not because they were threatened, apparently just because the masks were in the way. To understand what proportional force like this would mean for a human, a punch from a proportionally equipped human would not just break bones, it would produce a pressure wave. It would crack surfaces behind the target. The structural integrity of nearby walls would become relevant. Every casual disagreement would require an insurance form and a structural engineer. The shrimp just found a different set of rules and followed them further than anything else did. It just solved the engineering problem that human muscle never had to solve. Store the energy first, release everything at once. Let physics handle the rest. The deeper point is that this animal is not just strong, it is designed. The eyes track targets independently before the strike lands. The spring latch stores and releases energy more efficiently than direct muscle contraction. The club is reinforced with a helix structure that distributes impact force so it survives its own punch. The club regenerates when it takes damage. The UV vision reads signals that prey assume are private. Every system, targeting, storage, release, durability, visual processing, recovery, points towards the same moment. Contact, impact, done. This is not a creature that evolved one impressive feature, it evolved an ecosystem of systems that all serve the same outcome. The mantis shrimp is not brute force. It is brute force that also did the engineering homework, read the opponent's private communications, and arranged for the walls to help. Here is the thing about the mantis shrimp. It did not evolve any of this because something was watching. No selection pressure knew what a crossbow was. No mutation understood helix geometry. Nothing looked at ultraviolet light and decided it would be useful for reading private conversations. The mantis shrimp just kept solving problems that the deep sea kept making harder. And by the time anyone was paying attention, it had already been doing this for millions of years. Completely unbothered, completely finished, completely indifferent to whether you find it believable. You didn't discover the mantis shrimp. The mantis shrimp had already moved on. Next up, a fish with a transparent head. Not frosted, not cloudy. Transparent. You can see through the skull. The eyes are inside it, and they rotate. Which sounds like something a child would invent and no responsible biologist would confirm. The fish with a transparent head is real. The biologist confirmed it. Nobody slept well after. Click the next video or stay in the playlist, because the deeper you go, the worse it gets.